सो सॅम्पलिंग फॉर ऍट्रिब्यूट्स मध्ये आपल्याला जी सपोज जर डायकोटोमस क्लास, आता डायकोटोमस क्लास म्हणजे काय, तर फॉर एक्झाम्पल in a classroom there are number of males and number of females. So we have only two choices there, as the number of males, suppose there are a number of males, and number of females will be abbreviated as a complement. Okay, so the total number of students that will be reflected as a plus a complement, and that is equal to n. Okay, so dichotomous means the class having two subclasses. Okay, class means classroom having two sub classes as C and C complement. Okay, and if we add that two classes or do that two categories, okay, so you can get total number of individuals in that in the particular study. Okay, so if we consider the classroom of SYBSC STAT, okay, so A means number of boys and A complement means number of girls. Okay, and A plus A complement is equal to capital N. Okay, so here we not considering transgender. Okay, so sampling for proportion, consider a dichotomous population having two classes C and C complement. The classes म्हणजेच काय, मेल आणि फिमेल म्हणजे C आणि C complement. Okay, so let n be the number of individuals in the population. So मी काय म्हणेन की n be the number of students in the classroom. Okay, so classroom will be our population, or college will be our population. Okay, so A will be the capital A with the number of units belonging to class C in the population. In the population. Okay, and A complement with the number of units of the population belonging to the class C complement. Okay, so that A plus A complement is equal to N, and P be the capital P be the proportion of individuals belonging to the class C, and Q be the proportion of individuals belongs into the class C complement. So therefore we can find proportion as P is equal to number of individuals in class C divided by N. Okay, and Q can be find out as number of individuals in the C complement divided by N. But we know that the A plus A complement is equal to N. So A complement is equal to A complement, that implies A complement is equal to N minus A. If we put N minus A as A complement, you can get here N minus A divided by N, and by dividing each term of numerator by N, you can get N by N minus A by N. So that is equal to 1 minus P. So what is A by N? A by N means P. N by N means 1. So 1 minus P. And here the Q is equal to 1 minus P is we got relation Q is equal to 1 minus P. Okay. Suppose a simple random sample without replacement, SRSWOR. आता इथे आपण SRSWOR का स्टडी करणार आहोत, कारण का आपल्याला माहित आहे की SRSWOR चा व्हेरियन्स हा SRSWR म्हणजे विथ रिप्लेसमेंट पेक्षा कमी आहे, आणि त्यामुळे तो कन्सिस्टंट आहे. ओके, इफिशियंट आहे. सो इथून पुढच्या प्रत्येक सॅम्पलिंगला आपण SRSWOR काय करणार आहोत, स्टडी करणार आहोत. ओके, सो इन कंपॅरिझन करण्यासाठी आता स्ट्रॅटिफाईड मध्ये काय होतं, स्ट्रॅटिफाईड रॅन्डम सॅम्पलिंगचा व्हेरियन्स SRSW-OR पेक्षा सुद्धा कमी येतो. ओके, त्यामुळे तिथून पुढे आपण काय हे करणार, रिकमेंड करणार की you can use stratified random sampling for better efficiency. Okay, so suppose SRSW-OR of size n is drawn from the population. Okay, let small a. Now here comes the role of sample. Okay, so sample having sample size small n and a be the number of units in the sample belongs to the class C. A complement with the number of units in the sample belongs to the class C complement, and so that you can get relation A plus A complement is equal to n. P be the small a divided by n, Q be the A complement divided by n. So Q is equal to 1 minus P, as we can see, as we seen in last in population category. Okay, so here also you can write capital YI as units belong in the population, and small yi are the units belonging in the sample. Okay, so these are the indicator function. Indicator function means this can take only two values, 1 or 0. So that means yi is equal to 1, capital yi is equal to 1 means ith unit of the population belonging into the class C, and 0 if the ith unit of the population belongs to the class C complement. Okay, therefore if we take summation yi, so summation yi is represented as the number of ones. Okay, what means number of ones? So you cannot add 0. Okay, you cannot add 0. Okay, so summation yi means you can add only 1. Okay, 1 means ith unit belonging into the population, and that is equal to a. A means number of units in the population belongs to the class C. So summation yi is equal to a, and summation yi divided by n, it is equal to y bar. So this is the population mean. What is population mean? So population mean means y bar is equal to summation yi is equal to a divided by n, that is equal to capital P, that is population proportion. That is population proportion for the units belonging into the class C. Okay, so therefore Q is equal to 1 minus P. This is also another relation we seen in the last couple of minutes. Okay, so you can write as Q is equal to 1 minus y bar, capital Y bar also. Okay, and yi take values only 1 and 0. Yi take only values 1 and 0. So summation yi square can be represented as the square of 1 and 0. So 1 square is also 1, 0 square is also 0. So summation yi square also represents the number of individuals in the population belonging into the class C. So summation yi square is equal to a also, and summation yi square divided by n, summation yi square divided by n is also is equal to a by n, that is equal to p. So any power yi raised to k is also is equal to a, for k is equal to 1, 2, so on up to infinity, any value. Okay, because yi take only values 1 and 0. Okay, so 1 raised to k is 1, 0 raised to k is 0. Okay, So you can next, we can find out the sum of square or sum of deviation of square from mean. Okay, so summation I is equal to 1 to n yi minus y bar whole bracket square is equal to, okay, this can be rewritten as summation yi square minus n into y bar square. Okay, so this summation can be written as summation y square by minus n y bar square for better simplicity. And we seen this sum as summation y square minus n y bar square in semester 1 also, and in last when we derive the expressions for variance of sample mean and unbiased estimators, in that case also we can rewrite summation yi minus y bar square as summation y square minus n y bar square. So what means summation y square? Summation y square is np, and n is here also. Y bar square means p square. So np minus n we can common, or we can taking common np. So in bracket the remaining term is 1 minus p. Okay, so if you take np as a common constant, okay, so this is, if you taking np as a common thing, or np as a common term in both this term, okay, so you can get np into 1 minus p. So 1 minus p means q, so np q is there. So sum of deviation taken from arithmetic mean is equal to npq. Okay, so s square means 1 upon n minus 1 into sum of deviation taken from arithmetic mean. Okay, so this is equal to 1 upon n minus 1 npq. So this is n upon n minus 1 pq is there. Okay, so let yi be the values of the sample given by now. So this is the deviation taken from arithmetic mean for population. So similarly, you can derive the deviation taken from arithmetic mean in the sample, and the sample mean square small s square you can find out as a n small n divided by small n minus 1 small pq is there. Okay, so next, so sample proportion p is unbiased estimator of population proportion capital P. Okay, so this is E of P is equal to capital P. Before going to derive this statement, okay, we have to revise our theorem, okay, as in a simple random sample without replacement, sample mean is unbiased estimator of population mean. Sample mean is unbiased estimator of population mean. Okay, so what means sample mean in theory sampling for proportion? Sample mean y bar is equal to small p. Okay, and what means capital Y bar? What means capital Y bar? It is a capital P. So hence proof. You can prove this theorem by using, you can prove this statement by using the theorem sample mean in SRSWOR is unbiased estimator for population mean. Okay, so here we know that whatever I talk on sample mean, unbiased estimation of some population mean of in SRSWOR, which is written here. Okay, so we know that in SRSWOR sample mean is an unbiased estimator of population mean. So this is the case. Hence, expected value of small p is equal to capital P is there. Okay, so corollary, in unbiased estimation of total number of units is reflected as population total. Okay, So population total means summation yi. Okay. So summation yi, the unbiased estimator of summation yi is can be written as what is expected value of small p is equal to capital P. What means capital P? A by capital N. So if we multiplied capital N on both sides, okay, so here n get cancelled and expected value of capital N into small p is equal to A, which is the unbiased estimator of capital A. That means capital N into small p is unbiased estimator of total number of units in the population belonging to the class C. Okay. Then next statement is that variance of sample proportion. So we can find out variance of sample proportion as variance of y bar. Variance of y bar is equal to what means in variance of y bar in SRSWOR. What is the formula for that? Is written here. N minus small n, capital N minus small n divided by capital N, capital S square divided by small n. This is the capital S square. But we we find out the population mean square in proportion, sampling for proportion, and the formula for population proportion S square is capital N divided by small n minus 1 PQ, and you can put this formula in the variance of y bar. Variance of y bar means variance of small p. Okay, y bar means small p. So variance of p is equal to n minus 1 divided by n is taken out as it is here. Again, n divided by n minus 1 PQ and divided by n is taken as it is here. Okay, so this is the by simplification of step. You can rewrite as capital N minus n divided by n minus 1. So you can cancel out these two n minus n minus 1 PQ divided by n is there. This is the variance of the population. Okay. So again, variance for population total, that means total number of units belonging to into the class C as variance of capital N into small p, that is equal to n square. If you take outside of the constant, if you take constant term outside of the variance, okay, so you can get n square into variance of p, and n square into variance of p is equal to n square into variance of p is written as here n minus n divided by n minus 1 into pq divided by n. Okay, so this is the variance of the population total. Okay, again, standard error, you can take square root of these variances. You can find out standard error of p and standard error of np. Okay, so next, the estimate the variance of sample proportion in SRSWOR. We know that. So unbiased estimator for sample proportion, population proportion is the sample proportion. So in SRSWOR, another theorem or another result we have studied in last lectures as sample mean square is unbiased estimator of population mean square. Okay, so what means sample mean square? What means sample mean square? N PQ divided by n minus 1. What means population mean square? N divided by n minus 1 into PQ in terms of sampling for proportion. So if you take as for some if we taking some constant term to adjust the variance term, okay, so n minus n divided by capital N multiplying on both sides, you can multiply on both sides n minus n divided by capital N into small n. Okay, so you can find out that the expected value of n minus n into pq divided by n into n minus 1 is equal to n minus n into capital N minus 1 into pq, which is variance of p. So unbiased estimator for variance of p is phi hat p, okay, variance of small p, and it is equal to n minus n pq divided by n into capital N minus 1. These are all the simple terms. When you are studying or reading or trying to understand these terms, you can easily grasp all the terms, okay, of the variance, standard error, population total, unbiased estimation in theory of attributes. Okay, so estimate of variance of NP. NP means the population total. Okay, variance of population total. We know that the variance of capital N into small p as n square into variance of p. Okay, so we find out that the variance of p here, okay, and n square, by multiplying n square to the term, you can find out the variance of n hat p is variance of np hat is equal to n into n minus 1 divided by n minus 1 into np cube. Okay, so this is the case of estimate of variance of NP. So estimate of variance, standard error of sample proportion, you can take square root of this estimate. So you can get standard error, estimate of standard error of proportion. Okay. So next, again, estimate of standard error of proportion and estimate of standard error of population total. Okay, here. So here the theory of attribute, the derivations and the introductory part is over, and the last point in the unit 1 is the determination of sample size. Okay, is the